Question 5, we have a particle projected down an inclined plane. So we're going to have a slightly different diagram, and the speed is u, and the plane is inclined at 30 to the horizontal, and the line of projection makes an angle of 60 with the inclined plane. So our initial vector is going to be u cos 60 in the I direction plus u sine 60 in the j direction, which is equal to u over 2, cos 60 is a half. We have plus root 3 over 2 u in the I and j directions. My accelerations are going to be positive in the I direction because it's going down, so it's going to be positive g sine 30, and in the I j direction negative g cos 30. So that will give g over 2 and minus root 3 g over 2. I want the range here, the first hop, so it's going to say I want s of x when s of y is equal to 0. And actually the range to the first hop is just, it's going from here, and let's say it's getting to here. So we just want the s of x when s of y is equal to 0. So let's find the time. S of y, ut plus a half at squared. It's going to be root 3u over 2 times t. Acceleration is negative, root 3 over 2, so we get negative root 3g over 4, bringing in the half, times t squared. Factoring out my t, I get root 3u over 2 minus root 3 gt, that's a g, t over 4. When will this be equal to 0? I have my initial time is equal to 0, and I'll have root 3u over 2 will be equal to root 3 gt over 4. I can divide across by root 3 and multiply across by 4, and I'll get 2u equals gt. So the time taken is going to be 2u over g. So we can put this into our s of x. We'll get the range for s of x. ut, so we're going to get u over 2 for my initial velocity, times t, which is 2u over g, plus a half at squared, so plus a half times a, which is g over 2, times t squared, which is 4u squared over g squared. So this will give us 2u squared, no, the 2's will cancel, just u squared over g, plus 2's will cancel with the 4 and the g with one of the g's, so we're just going to get u squared over g as well, which is equal to 2u squared over g for the range in the x direction to the first hop. Then we're asked for what value of e is the range for the second hop double the range for the first hop. Well, double 2u squared over g, we multiply that by 2. We're going to get 4u squared over g, would have to be my new range. So a bit of work involved here, isn't there? So here's my particle getting projected down at where it's going to land here at this point. So we need the velocities at landing, and then it's going to take off again and have an even bigger hop. So we need to get definitely v of x and v of y at this time t, 2u over g. So v of x is going to give me u over 2, u plus at, u over 2 plus at plus g over 2 times t, which is 2u over g. Maybe put a box around it. So that's going to give u over 2 plus u, so that's going to be 1.5u or 3u over 2. That will be in the I direction. Velocity of y is going to be root 3u over 2 plus AT is going to be minus root 3g over 2 times t, which is 2u over g. Cancel my g's and my 2's, and I'm going to get root 3u over 2 minus just root 3 u. So it's like I've got root 3u over 2 and over root 3. So I've got a full 1.5 once, so I'm going to end up with minus 1/2, 1 minus root 3u over 2. So the new velocity will be, so well, my landing velocity, I'll write that out first. My landing is 3u over 2 in the I direction minus root 3u over 2 in the j direction. So my new velocity is going to be 3u over 2 in the I direction plus, I'm going to multiply this guy by minus e, and we have plus, then it goes by minus e plus root 3 ue over 2 in the j direction. Now for what value of e is the range for the second hop double the first? Okay, so we have the 4u squared over g. So there's a lot of work involved here, I think, because if we imagine it's coming down, there's the first hop, now here's the second hop, we need u. There's an angle in here we'll call A, and it's going to come down the plane and land here. And we have this angle again to the horizontal, we know is 30. So I think the first thing we'll do here is we'll get the magnitude of this velocity vector here to get u. So the square root of 3u over 2 to be squared is 9u squared over 4. Call it the magnitude of u. And then plus 3u squared e squared over 4. So I can factor out, if we can create a product inside the square root, we can get the square root of each. It might make it a bit simpler. I can factor out 3u squared over 4. That would be multiplied by 3, just 3 plus 3e squared. Is that right? No, 3, just 3 plus e squared, just 3 plus e squared. Okay, that might tidy up a little bit for us, because that's the square root of 3 by the square root of u squared, which is u, over the square root of 4, which is 2, by the square root of 3 plus e squared, which I don't think we can simplify it down any further. So that is the magnitude. So now the angle, we have the tan of the angle A. The tan of A is going to be this velocity of y over velocity of x from up here. So root 3 ue over 3 over 2. Well, we'll just knock out the 2's. They're going to cancel over 3u. So that's just going to give root 3 over 3. If I multiply top and bottom by root 3, I'm going to get 3 on top, 3e, and on the bottom I'm going to get 3 root 3. So then that just looks like the tan of A is equal to e over root 3. And if the tan of A is e over root 3, we can now get the cos and sine of A. There's a better way to do this, please let me know. Opposite over adjacent. So this is going to be the square root of root 3 squared, which is 3 plus e squared. So now the cos of A is root 3 over the square root of 3 plus e squared, and the sine of A is going to be opposite e over the square root of 3 plus e squared. Okay, let's see next. We have our u, We have our angles. Now we need to set up our accelerations. They're going to be the same as before. So let's just write down what our accelerations were. It was g over 2, wasn't it, for my accelerations? Just follow it with g over 2 and minus root 3 g over 2. Minus root 3 g over 2. So if I set up my new vector, it's going to be u cos a, so root 3u over 2 by the square root of 3 plus e squared times the cos of a, which is root 3. Now we can see here we're definitely on the right track. The square root of 3 plus e squared is going to cancel for us. So that's u cos a in the I direction plus u sine a in the j direction, root 3 u over 2 by the square root of 3 plus e squared. That's my u times t, by the sine of a, which is e over the square root of 3 plus e squared in the j direction. Tidying this up, it looks like we're going to get 3u over 2 in the I direction, tidied up eventually, and then plus root 3 ue over 2 in the j direction, root 3 eu over 2 in the j direction. So if we find s of y now, it's going to be equal to u root 3 eu over 2 times t plus a half at squared is going to be minus root 3g over 2, and the half will bring it up to a 4 by t squared. When is this equal to 0? Factor out my t to get root 3 eu over 2 minus root 3 gt over 4. So I have my initial t equals 0 at the first bounce, and I would have root 3 eu over 2 would be equal to root 3 gt over 4. So multiplying by 4, I get 2 eu, and then dividing by g will give me the time taken for the first bounce. So then if I find s of x at this time, s of x is equal to ut, so 3u over 2 from here times this t, which is 2eu over g, plus a half at squared, so plus a half by g over 2, my a, and then my t squared will give 4e squared u squared over g squared. So tidying up the first one, I'm going to have 6u squared e, oh, I can cancel out the 2's, I'm going to have 3u squared e over g, and then tidying up the second one, the 2's will cancel with the 4, I'm going to have the g cancelling with the g, and I'm going to have e squared u squared over g, e squared u squared over g. I have no idea if this is right, this looks ridiculous. If we factor out u squared over g, we're going to be left with, well, I can factor out u squared, I'll factor out eu squared over g, so that would leave me with 3 plus e inside. So this is my range, and it has to be, what was it, 4u squared over g or something? 4u squared over g has to be this range. So this is equal to 4u squared over g, multiplying by g, dividing by u squared. Oh, we're tidying this up now. That's going to give me 3e plus e squared equals 4 minus 4 equals 0. E squared plus 3e minus 4 equals 0. I've never been so happy to see a quadratic equation in E in my life. E times E, 4 times 1 plus 4 minus 1 gives plus 3e. So e is equal to 1 or minus 4, and e cannot be equal to minus 4. So after all our work, we get the final answer of e being equal to 1.